Happy snow day, everybody. Hopefully you're staying warm and safe here. Now, if you remember Thursday in class, we started working on section 1.3, our advanced probability section. And there's 4 questions in that. We tackled combinations with equally likely outcomes and combinations with not equally likely outcomes. Okay, today what we're going to do in this video is the last 2 questions dealing with tree diagrams and Venn diagrams. Okay, so grab your note guide. You can follow along, fill things in just like you would in class, and we'll even give you a chance to pause the video, get some practice in. Here we go. The first type of problem we're going to look at today deals with tree diagrams. Okay, and as far as how you know you have a tree diagram problem, that's going to happen anytime you have a conditional probability. Okay, in other words, an event whose probability is conditional upon other events taking place. Okay, so let's take a look at that. Problem A says, if it snows more than 6 inches, there's an 80% chance that school closes. If it snows less than 6 inches, there's only a 5% chance school closes. If there's a 60% chance that it will snow more than 6 inches, what's the probability school will close? Okay, again, I know this is a tree diagram question because the probability that school closes is either 80% or 5% based on it snowing or not. Okay, so that's the conditional piece. So let me show you how we can map this out with a tree diagram. Okay, closing and not closing is based off 2 conditions. So those will be our first 2 branches. One for the snow and one for no snow. Okay, now the problem ends with there's a 60% chance of snow, so on the snow branch I'm going to put a 0.6, meaning that if I take 1 minus 0.6 I get a 0.4, so there's a 0.4 probability that it won't snow. All right, now whether it snows or not, school could close or remain open. That's kind of my next set of branches. And it could not snow and school could be closed or remain open. All right, and again, that probability is conditional on whether it snows or not. Okay, if it snows, okay, we said there's an 80% chance that school closes. So I'm going to put a 0.8 for probability on that branch, meaning that there's a 0.2 probability they'll remain open if it does snow more than 6 inches. Okay, if there's no snow, there's only a 5% chance school closes. Okay, usually school doesn't close if there's no snow. So we'll put a 0.05 probability on the no snow and close branch. And then there is a 0.95 probability that it remains open. All right, we want to know what's the probability school will close. Now that's with or without snow. So the way we'll calculate that is we'll look at the probability that it snows and closes. We'll follow this branch. Like we said, snow and closes. Anytime you see and in probability, that's a multiplication problem. All right, so we'll multiply up the branch, 0.6 times 0.08. Sorry, 0.8 gives us a 0.48. Okay, so it could snow when school closes. All right, or, so I'm going to say plus, there could be no snow and it closes. So we'll follow that branch, no snow, and so times again, close. So multiplying along those branches, we have a 0.4 times 0.05, which gives us a 0.02. Okay, so we have the probability that it snows and closes, that it doesn't snow and closes. We can use either or, so we'll add these together. So I'll combine these 2 probabilities for a final probability of 0.5 Okay, that school closes either way based on these given conditions here. Okay, there's an example of a tree diagram problem. Why don't you pause the video, try to work through B on your own, see if you can get the answer, and then hit play and we'll run through it together quick and check the answer. Alright, let's run through part B together so you can either get your questions answered or check your answers. Okay, we have a college that found 90% of its graduates are happy with their job, and for its non-grads, 60% were happy. If the college has an 85% graduation rate, what's the probability that a student who goes there will be happy with their job? Okay, conditional probability because whether they're happy or not, that probability depends on whether they graduate. So let's map that out. We're going to make graduates and non-graduates our first branch. So we'll say grad and non-grad. There's an 85% graduation rate, so we'll put a 0.85 on the grad branch, meaning there's a 0.15 for the non-grads. And if they graduate, they can be happy with their job. Or I suppose we could say sad. And if they don't graduate, they can still be happy or sad with their job. If they graduate, there's a 90% happiness rate, so we'll say 0.9. Non-grads, we'll say 0.1. And for the non-graduates, there's a 60% happy rate, meaning there's a 0.4 probability for non-graduating and being sad. Again, we want to figure out the probability that they're happy with their job, and that's going to be graduating and being happy. So 0.85 times 0.9, that's going to give us a 0.765 probability. Okay, or they could not graduate and still be happy. So 0.15 times 0.6, that's going to give us a 0.09. Either or, so we'll add. So I'm going to add those two probabilities together and end up with a 0.855 for probability that they're happy with their job. The next thing we're going to look at are some problems that utilize Venn diagrams. Now, as far as knowing when to use a Venn diagram, they're going to be handy anytime we have some probabilities that overlap. So for example, when I read this question, the both is going to be the key word that lets me know this is going to use a Venn diagram. Okay, so let's take a look at the problem. It says a survey found that 20% of Americans watch The Voice, 15% watch America's Got Talent, and 10% watch both. And then based on that, there's two things we want to figure out. We want to know what percentage of Americans watch The Voice, but not America's Got Talent, and then what percentage of Americans don't watch either show. Okay, so a Venn diagram is kind of a blob diagram to show relationships. So I'm going to make a big blob here and say that this represents America. Let's say USA here. Okay, now within Americans, there is a chunk of the population that watches The Voice. And there's a chunk of the population that watches America's Got Talent. We'll just say AGT. And I made these two smaller circles overlap because there's a chunk of the population that overlaps that watches both of them. Okay, we want to fill in kind of each section of this Venn diagram with probabilities. And you're going to want to start with the both part. 10% watch both, so I'm going to put a 0.1 in that middle, in that overlap. What I want to figure out next is what percentage of Americans watch just The Voice, but don't overlap with America's Got Talent. So what I'll do for that is I'll take this 20% for America's Got Talent, so 0.2, and I'm subtract the both, the 0.1. Okay, and that's going to leave me with another 0.1 or 10% for just The Voice and not America's Got Talent. Okay, we'll do the same thing for finding the people who just watch America's Got Talent without The Voice. We'll take the 15%, so 0.15, and again subtract the overlap, the 0.1, which is going to leave us with a 0.05 probability that they watch just America's Got Talent and not The Voice. Okay, at this point, we can answer our first question. What percentage of Americans watch The Voice but not America's Got Talent? Well, that's going to be the 0.1. So we could say P of The Voice, as in just The Voice, and we can say that's equal to a 10%. Okay, second question we want to answer is what percentage of Americans don't watch either show? So in other words, what probability is left on this outside of these pieces? Well, to calculate that, what we'll do is we'll take a 1, as in 100% of Americans. I'm going to subtract each of these parts, so the people who watch just The Voice, so minus 0.1. Okay, the people who watch both, so minus another 0.1. And the people who watch just America's Got Talent, so minus 0.05. Okay, which leaves us with a 0.75 for probability that a person doesn't watch either show. So we could say P of neither, and that's going to be equal to 75%. All right, again, Venn diagrams work really well for showing relationships between kind of overlapping categories. And the types of questions we could ask you are about basically, how the different blobs or what's outside the blob relate to each other and what their probabilities are. Once again, I want you to pause the video, give part B a shot, and then hit play to check your answer. All right, B, we have another Venn diagram problem. And again, it's because of the overlapping probability, this both keyword. Okay, so we have a high school with 40% of students in band, 30% in choir, and 10% in both. Let's map that out here. We've got the school. We have band, choir, and they overlap with the both. The both is 10%, so I'll say 0.1. To figure out just the band, we'll say 0.4 minus 0.1, which gives us a 0.3. To find that just the choir, we'll take the 30%, so 0.3 minus the overlap, 0.1, which gives us a 0.2. So for the first question, what percentage of students are in band but not choir? We'll say P of just band. That is this 0.3, so 30%. And for the second question, we want to know the neither part, what percentage of students aren't in anything. Again, for that, we'll take the whole school, the 1, minus the 0.3, minus the 0.1, minus the 0.2, so minus all those parts. And that leaves us with a 0.4. So the probability of neither is equal to 40%. All right, so that's it for lesson 1.3. Give the rest of the homework the shot. Get that wrapped up sometime over your extended weekend here. And then like we said in class on Thursday, or maybe we said it, we are going to quiz you when you get back on Tuesday. Okay, so that'll be in sections 1, 2, and 3. So study up. If you have any homework questions, bring those in Tuesday morning. Get those taken care of. Otherwise, we'll see you Tuesday.